Acetals are formed in two steps. We can write it as a two-step reaction, or we can just write it as a single-step reaction. I'm going to start by writing the two-step reaction. Remember, acetals are formed from some kind of a carbonyl. So that means we are either going to form them from a ketone or an aldehyde. The first example that I'm going to show is going to be the formation from an aldehyde. And the aldehyde that I'm going to use is butanal. So I've got 1, 2, 3, 4 carbons, and just remember there is a hydrogen here. We don't show that, but it is there in the bond line notation because this carbon right here has 1, 2, 3 bonds. The fourth bond is to hydrogen. In order to form the acetal, we first need to form the hemiacetal, and we're going to do that by adding one molecule of 1-propanol. So here's our alcohol group, carbon 1, 2, 3. So that's propanol, 1-propanol. We're going to do this with an acid catalyst, so I'm putting the H plus there. In order to form this hemiacetal first, what happens is this hydrogen ends up on that oxygen, and this oxygen attaches to what right now is the carbonyl and will now be a carbon that's bonded to 4 things instead of 3. So I'm going to draw our hemiacetal product. Remember, our basic carbon chain, 1, 2, 3, 4, does not change. So there is our bute base that we started with. And now we will have an OH group where the carbonyl was. And we will now attach this alkoxy group, the O connected to the propyl, to our former carbonyl carbon. So this is a hemiacetal. It's a hemiacetal because we have a carbon singly bonded to 2 oxygens. One of the oxygens is an alkoxy group and the other is a hydroxy group. So this is a hemiacetal. And also remember that H that we don't show in the bond line notation is there. This hemiacetal, which I'm going to redraw, can then react with another molecule of our alcohol. I'll draw the alcohol the same way that I had before. So 1, 2, 3, 1-propanol, and our hemiacetal, and we will react with some acid in order to catalyze the reaction. And what will happen is this OH and this H are going to get together, and the O is going to connect right there. So we will draw our carbon chain, which does not change, and now we have a single bond to an oxygen, and the alkoxy group is there. Here is the original alkoxy group that was there from the hemiacetal. And so now we have an acetal. And the acetal is a carbon singly bonded to 2 oxygens, both of which are alkoxy groups. Remember the H that I put in parentheses up here that we don't show in the bond line structure is there. And so this is our formation of an acetal. The other side product is 1 molecule of water. Now, as I mentioned in class, both of these reactions are reversible. This is the reaction for acetal formation. These are unstable, so they can very easily go back to being the hemiacetal, and the hemiacetal can very easily go back to being the aldehyde.